In section 6.6, we're going to stick with looking at compound probability, but now we're going to take a look at the addition rule. So in yesterday's lesson, when we see the word and, we should think to multiply. Now, when we see the word or, we should think to add. And that's going to lead us to the addition rule. The addition rule is for the probability of event A or B occurring, we add the probability of event A and the probability of event B, and then we subtract any overlap, so the probability of A and B occurring together. Now, this is going to be an important topic considering if the events are mutually exclusive. So if event A and B are mutually exclusive, meaning they can't happen together, that overlap is going to be irrelevant and the probability of A and B is just going to be 0. So we've already kind of looked at the probability of A or B before, but we've only looked at mutually exclusive events. It's just when things kind of can happen at the same time is where we have to think about overlap, so that's what we'll really focus on in today's video. So to start off pretty simple here, on a standard die, we've done a problem like this before. What's the probability that we roll a 5 or we roll a 2? Now just thinking about that logically, I can't roll a 5 or a 2 at the same time, so there's not going to be any overlap. So I'm going to add, I'm just going to kind of write everything out for the whole addition rule and we'll go from there. Probability of rolling a 5 plus the probability of rolling a 2 minus the probability of rolling a 5 and a 2. Again, as we said before, that can't happen at the same time, so that probability is just going to be 0, or we can just kind of not even think about it anymore. All I'm really going to do is add the probability of rolling a 5 plus the probability of rolling a 2, which is 1 over 6 plus 1 over 6, which will be 2 over 6, which I could simplify to 1/3. Now let's get a little bit more complicated. What if I want to figure out the probability of rolling a multiple of 3 or an odd number? So that's probability of rolling a multiple of 3 plus the probability of rolling an odd number minus the probability of rolling a multiple of 3 and an odd number. Now, I might be thinking here, is there going to be any overlap? If I write out everything in my sample space, which again is just the numbers 1 through 6, I can know for sure. So these are all the possible numbers that I could roll. Let's start by looking at multiples of 3. As we talked about before, multiples of 3 is anything that divides by 3, so that could be the number 3 or the number 6. So the probability that I roll a multiple of 3 is 2 options out of 6. And I'm going to add the probability of rolling an odd number, which we know would be 1, 3, or 5. So 3 options out of 6. Notice here how the number 3 I counted in both categories. So as of right now, I'm like double counting it, and like where I'm including it in a multiple of 3, and I'm including it as an odd number. So I need to subtract that overlap. So a 3 counted for both of them. Rolling the number 3 is a multiple of 3 and odd, so I'm going to be doing 2 out of 6 plus 3 out of 6 minus 1 out of 6. Easy calculation here in the sense that these have the same denominator, so I'm just really doing 2 plus 3 minus 1 over 6, which is 4 out of 6, or 2/3. Let's look at one more example looking at a chart here. When we have our stuff in a chart, there's a shortcut that we can do for these kinds of problems, which we'll go over in class. So let's say I take a survey of 50 students. I mark down whether they're a girl or a boy, and I want to know if they're a student athlete or not. So if they play a sport or they don't play a sport. And these were the results that I got. And let's say I want to pick someone randomly in that survey, and I want to figure out what's the probability that I choose a girl or someone that plays a sport. Again, I see the word or, so I'm going to think addition. So I'm going to add the probability of picking a girl plus the probability of playing a sport minus the probability that I pick a girl that plays sports. Just thinking about the problem logically here, there's going to be some overlap because you can be a girl and play a sport at the same time. These are not mutually exclusive events. So I'm going to add the probability that you're a girl, which is 30 out of 50, plus the probability that you play a sport, which is also 30 out of 50. And notice here that when I kind of highlight the stuff in, there's those 20 girls that play a sport that I double counted for, so I need to subtract that overlap again. So minus 20 out of 50. So I'm doing 30 plus 30 minus 20 out of 50, which ends up being 40 out of 50. If I want to simplify that fraction, that'd be 4/5 or 80%. And I'm done.